I want to find the derivative of x to the ln of y equals 2. So I'm going to show you how to do this using two methods. Okay, so the first approach, whenever you have, let's say, a function to a function, whenever you take the derivative, it's always going to be the original function multiplied by ln of the base times v, and then this whole thing you're taking the derivative. Okay, so in this case you have the derivative of ln of u times v. You can think of this as just u to the v and then multiplied by the derivative of v times ln of u. Okay, so this v is not part of the ln of u. Alright, so for us, u is going to be x, v is going to be ln of y. So we're just going to plug it in here. We have x to the ln of y times v, which is ln of y, and then multiply that by ln of u, which is ln of x. And then we're going to take the derivative of the parentheses. Okay, so that's the left side. And then we have to take the derivative of 2, which is 0. Now I can divide both sides by x ln of y, and I'm allowed to do that because that is never going to be 0. Okay, if x to the ln of y was 0, you can never divide by 0. Okay, so I could do that in this case. So we have the derivative of ln of y times ln of x equals 0. And now let's find the derivative. So for the derivative, we have to use a product rule. First, take the derivative of ln of y. So that's 1 over y times y prime. So you can also, if you want, you can write dy over dx in place of y prime. Okay, so that's the derivative of ln of y, and then we're going to multiply it by ln of x. Now I'll take the derivative of ln of x and multiply it by ln of y. The goal here is to solve for y prime. So first, why don't we just subtract the 1 over x ln of y to both sides. And we want to isolate now y prime, so that means we have to multiply both sides by y and then divide by ln of x. So we end up having negative y ln of y over x ln of x. Okay, so this was the derivative using this first method. So I'm going to show you how to find the derivative using another method. Okay, so this method, we're going to have to rewrite the original function. X to the ln of y is equal to 2. Okay, I'm going to rewrite this. So in general, I know that e to the ln of x is equal to x. So x to the ln of y will replace x here. So that's going to be e to the ln of x to the ln of y. Okay. So these are similar, they're equal. And now, one of the log properties is that the log brings the exponent in front. So like whenever you have, let's say, ln of x to the n, that's going to be n times ln of x. So same thing here, ln of y is the exponent, so that's just going to be e to the ln of y times ln of x. So this is just algebra. I'm not taking any derivatives yet. Okay, so that's what I'm going to replace x ln of y with over here. So that's going to be e to the ln of y times ln of x is going to equal to 2. And now I should be able to find the derivative. Okay, so with a derivative, it's basically the derivative of e to the x is itself. So it's just going to be e to the ln of y times ln of x. But now we have to take the derivative of the exponent. And the derivative of 2 is just 0. I can multiply both, or rather I can divide both sides by e to the ln of y times ln of x. We know that e to any power is never 0, so that's going to cancel. And I'm just left with the derivative of ln of y times ln of x. For that, we're going to use the product rule. So we want to take the derivative of ln of y, which is 1 over y prime, times ln of x, plus the derivative of ln of x times ln of y, which is equal to 0. Solve for y prime. Well, first let's move the 1 over x ln of y to the other side. And then multiply both sides by y and divide it by ln of x to get that y prime is going to be negative y ln of y over x ln of x. And this is exactly the same answer as we got before.